So I'm going to change this predict word to describe just to focus again on some of the key words that come up on your exam. So when I handed out your formula sheet, the blue sheet, on the back of it are key explanation words for your exam, and one of them is describe. So if you have a question that says describe or explain, they're expecting you to use words and words only. So sometimes there might be something that you could show it using math, but because they use the word describe, they won't look at your math. Or in a describe one like this, describe how the graphs look. If you drew your graphs, they actually tell us when we're marking it to ignore all graphs and just read the words. Don't use what they may understand what's happening, but because they didn't follow the word describe, to show only words. So just as practice, we'll be throwing words like this in there just so we can get used to it. So if I was to describe the words, what could I do? Well, I'm going to go across and look at each of the numbers and describe not only what it does with transformations, but also describe the special thing as it's related to sine and cosine graphs. So first of all, the 1/4. So we'll say the graph has a vertical compression by a factor of 1/4. So that would be the transformation description of what the 1/4 does. Specifically, that 1/4 means the amplitude is 1/4. So I described the transformation wise, and now the amplitude is 1/4 instead of 1. The 3. Maybe I'll do them, maybe I'll make it nice and neat one at a time. So the first thing we looked at was the 1/4. Now looking at the 3. The graph has a horizontal compression by a factor of 1/3. So that's the description with transformations. And specifically, that means instead of the period being 2 pi, the period will be 2 pi divided by that b value, or 2 pi over 3. The next number is the pi over 6. There's a translation, pi over 6. Is it plus pi over 6 or minus? Plus, so pi over 6. To the left. Now, as far as our starting point goes, since this is a cos graph, and a cos graph starts at a maximum, we now know that that maximum has been shifted pi over 6 to the left. And finally, the plus 2. There is a translation. Two units up. And this is our d value. So our sinusoidal axis is at y equals 2. So I described them from left to right just like my transformations normally. And I also described specifically what the d, the a, and the b value do. The d value is your sinusoidal axis. your A value is your amplitude, and your B value helps you find your period. Now in part B, it said to actually graph this one. So off to the side here, just to remind us of our DAB C, we start with our D value. Sinusoidal axes. At y equals 2. Then we go to our A value. And with our A value, we mark our maximum and our minimum value. So our A value is 1/4. That means we're going to go from our center line, which is at y equal 2, and go up 1/4. That'll be at 2.25. And down 1/4. That'll go down to 1.75. This is going to be a very skinny coast graph in the end. So we've done our D value, which was our center line. We then used our A value and our D value to mark our maximum and our minimum. Now we're going to use our B value to find our period and to split it into 4 equal sections. Now since our B value was 3 and we know that our period is 2 pi over 3, I'm going to mark 2 pi over 3 on my graph, and I'm going to divide that into 4 equal sections. So half will be pi over 3, then pi over 6. 3 pi over 6 was pi over 2. And so once you've completed the D, the A, and the B, the DAB, you can now temporarily graph it. This is a coast graph. Where does a coast graph start? At a maximum. So you start at your maximum, go to your middle, down to your minimum, back to your middle, back to your maximum. And this is just a temporary graph, so I'll just do it in a dotted line here. And then finally, we take our temporary graph, we apply our C value, which is our shift. We're shifting this one pi over 6 to the left. So on my graph, I can mark pi over 6 to the left will go to minus pi over 6. This maximum point will go there. This one will move over and shift all of your points pi over 6 to the left. And there you have your final graph. Okay? Now, that graph that we just did is just a partial graph. Now that we have that graph, and I would suggest we always start by doing our graph that way. Now that we have our graph, we can say, this question said, sketch the graph between negative 2 pi and 2 pi. So now underneath here, I'm going to look at if I had to sketch it all the way to negative 2 pi. And all the way up to 2 pi. And if I look at the scale that I'm using that I need for my graph here, can you see that I need to have a pi over 6 marked? Yes? That each one of my ticky marks on my graph when I originally drew it were by pi over 6. So if I want to graph it between negative 2 pi and 2 pi, how many pi over 6s are there in pi? 6. So I'm going to divide this into 6 sections. And then another 6 sections here. So that I have pi over 6 marked there. Same thing here, I've got negative pi. I'm going to divide this into 6 sections and this into 6 sections. Still show my sinusoidal axis on here. I can still mark my maximum, 2.25, my minimum at 1.75, and now I'm going to take the points that I have here and say it started at a maximum at negative pi over 6. And then at each ticky mark, it switched, so I can go down to my middle, to my minimum, to my middle, to my maximum, middle, minimum, middle, maximum. And so you can see that this is just a little tedious, especially on a smartboard where you can't really see where your dots are going exactly. Which one was I on? There we go. There we go. So that would be the graph between negative 2 pi and 2 pi. Notice on my original graph, when I was just doing a general graph, I put arrowheads on to say it goes on forever. On this graph, because it asked to graph it between negative 2 pi and 2 pi and include those values, on this graph I stopped at that point. Generally on an exam, they'll say, can you graph at least one period? They're looking for the graph that we did at the top. But the graph that we do at the top is the easiest way to start, and then if you need to graph it over another domain, then you can use that to graph afterwards. Okay, so we're going to take some time to practice. 3, 8, 9, 10, and 11. And remember, back from our transformations unit, with the B and the C value, anytime you have a horizontal stretch or a reflection, along with a horizontal translation, it needs to be in factored form first. So I think there's some, I think it might be question 11 where you have to factor before you can apply your transformations.